Hey everyone, and welcome. Today we're diving into something that seems super simple on the surface, but is actually pretty tricky under the hood. We're talking about how a calculator knows that multiplication comes before addition. We're going to break down the logic, the secret sauce that lets a computer follow the order of operations, and we'll solve a classic coding puzzle while we're at it. I mean, really think about it. When you see 3 plus 2 times 2, your brain just knows to do the multiplication first, right? It's automatic. But a computer, it just sees a line of characters. It has zero intuition. It needs a system, a strict set of rules that we have to build for it. So, how do we actually build that logic from the ground up? That's the real puzzle here. Because if a computer just reads left to right, well, it's going to get the wrong answer almost every single time. It needs a rock-solid method to follow that one fundamental rule we all learned back in school: multiplication and division always get priority over addition and subtraction. And this right here just lays it all out, plain and simple. On the left, you've got the wrong way, the simple left-to-right method. 3 plus 2 is 5, then 5 times 2 is 10. Totally wrong. But on the right, that's the right way. We handled the 2 times 2 first, which gives us 4. Then we add the 3, and boom, we get the correct answer, 7. Our entire job is to program the logic on the right. Now, the problem we're looking at from LeetCode actually gives us a little help. It guarantees the expression will be valid. So, no weird stuff like 2 plus signs in a row. But honestly, that's not enough. We still need a system, a really specific way to handle this. And for that, we're going to need a special tool to help us manage the order of things. So let's bring in the hero of our story, the stack. It's this simple but incredibly powerful data structure that is just perfect for this kind of hang on, do this later logic that order of operations is all about. So what is a stack? Well, its entire world revolves around one single simple rule: last in, first out. You might see it called LIFO. All it means is that the very last thing you put on the stack is the very first thing you have to take off. You can't cheat, no grabbing from the middle, no sneaking something from the bottom, only the top. The classic way to think about this is a stack of plates. Seriously, imagine you put plate A on the table, then you put plate B right on top of it. Now, if you want to get to plate A, you have no choice, right? You have to take plate B off first. The last plate you put on is the first one that has to come off. That's LIFO. That's our stack. Okay, so we've got our tool. We understand how it works. Now, let's map out the game plan. How are we going to use this simple stock of plates to solve our math problem and make sure we follow the right order? All right, here's the core algorithm. It sounds like a lot, but it's pretty slick once you see it. We're going to scan the expression one character at a time. The real trick is that we're always looking at the last operator we saw, okay? So if we see a number, we just build the number. But the moment we see an operator, or we hit the end of the string, that's when the magic happens. If the last operator was a plus or a minus, we just push the number we just finished building onto our stack. Simple. But, and this is the key part, if the last operator was a multiply or divide, we pop the last number off the stack, do the math with our current number, and then push the result right back on. See what that does? It forces multiplication and division to happen immediately, while the addition and subtraction just kind of wait patiently in the stack. Finally, when we're all done, we just add up whatever's left in the stack. Okay, theory is one thing, but let's actually see this thing work. It's time to put it all together. We're going to walk through our expression 3 plus 2 times 2 step by step, and you'll see exactly how the stack does its thing. Okay, step 1. We start at the very beginning with the character 3. That becomes our current number. Now, since there's no operator before it, we're just going to pretend there's a plus sign there by default. It makes things easier. At this point, our stack is completely empty. All right, now we hit the plus sign. That's our cue. It tells us we're finished with the number 3. So we look back at the previous sign, which was that default plus we set up. The rule for plus is super easy. Just push the number onto the stack. So in goes the 3. And then we update our previous sign to be the plus we just saw. Moving on, the next character is a 2. It's a number, so that becomes our new current number. The last sign we saw was plus, and for now, the stack just hangs out with a 3 in it. Nothing else happens just yet. Okay, and now we hit the multiplication sign. This tells us we're done with the number 2. So what do? We look at the previous sign. What was it? It was a plus. And our rule for plus says to just push the current number onto the stack. So the 2 gets pushed on top of the 3. Our stack now has 3, then 2. And finally, we update our previous sign to be the multiplication symbol we just hit. This is the crucial step. We process the very last character, another 2. and that's our current number. But now we're at the end of the string. The end of the string acts like a final operator, forcing us to process that last number. So we look at the last sign we saved. It was multiplication, star. And what's the rule for multiply? We pop the top number off the stack, which is a 2, and we multiply it by our current number, which is also a 2. That gives us 4. Then we push that result, 4, right back onto the stack. And just like that, you see it? The stack transforms from 3-2 to 3-4. The multiplication happened right then and there. And there you have it. The order of operations has been totally enforced. The multiplication was handled immediately on the spot, while that addition just waited patiently. The hard part is officially over. Now for the super easy finale. All we have to do now is add up everything that's left in our stack. What do we have? A 3 and a 4. Add them together, and you get 7. The correct answer. Our algorithm with our simple little stack worked perfectly. So you might be thinking, okay, that's a cool trick for one specific coding problem. But the truth is, the idea behind this is so much bigger. This is way more than just building a calculator. This whole stack-based approach, it's a foundational concept in computer science. This is basically how compilers figure out the code that you write. It's how fancy scientific calculators can handle all those nested parentheses and complex formulas. Really, it's how any system processes a sequence of instructions where some things absolutely have to happen before others. It's a master pattern for enforcing rules and order. And that really leaves us with a final thought, doesn't it? We just solved a tricky math problem using a tool that's as simple as, well, a stack of plates. It kind of makes you wonder, what other complex-looking problems out there are just waiting for a simple, elegant solution?